Hi, and welcome to this section of the Pre-Algebra Tutor. And in this section, we're going to study the topic of what we call factors and multiples. Now, let me tell you right now, there are a lot of topics in pre-algebra that sort of seem disconnected from one another, First, we learn how to add, subtract integers, then we learn how to work with exponents and order of operations, and they might seem like disconnected topics, just like this one on factors and multiples might seem like to be a disconnected topic. But what you're going to find is that they're like a string of beads on a string, and you must learn one before you learn the next one, and before you know it, you'll have a bag of skills so that when you get down the road a little bit to expressions and equations and some of these things that we're going to be doing a little bit later, all of these topics are going to be necessary. So you may not quite see the point of understanding these little individual topics that we have now, but once we get to some of the topics later on, you'll understand why it's so important. In this particular case, factors and multiples, factoring is a huge part of algebra and pre-algebra, and you'll see why when we start dealing with expressions. And multiples are very important also, especially when we start talking about fractions and simplifying fractions in pre-algebra. So with that, let's talk about factors and multiples. The good news is these two topics are very, very simple. They just have funny names that you might not know at first, but we're going to break through that right now. A factor is the following. Let's go ahead and write it down word by word, and then we're going to use a lot of examples to show you that it's really not that big of a deal. So what we're going to say is we're going to say the factors, this is a sort of a definition that you'll need to remember, so I'm going to underline it. The factors of a number, and I'm writing it all in terms of numbers here because you have some experience with numbers, you understand numbers, but everything we're writing is going to apply to algebraic expressions. In other words, things that have letters in them, A and B and X and Y and things like that. These are all going to apply. The factors of a number, or an algebraic expression later on, are, when we're talking about numbers, are the whole numbers that we can multiply together to get that number. All right, now you might look at this and say, well, that sure does look like a complicated definition. It looks like a lot of words here. But really, it's a very, very simple idea. Basically, what we have for a factor, when you're talking about the factors of something, we'll take a quick example. The number 10 you've dealt with all your life. You have 10 fingers, you have 10 toes, right? But we know that for the number 10, we can say that 1 times 10 is equal to 10. That's a true statement. We know that that's true. And we can also say that 2 times 5 is equal to 10. So these are all whole numbers that can be multiplied together. 1 times 10, 2 times 5. And they can be multiplied together to give you 10. So what we've learned from this is the factors, which is the word we're trying to learn here, of the number 10 are 1, 2, 5, and 10. That's it. So if on a test you were asked, what are the factors of the number 10, or what are the factors of the number 12, or whatever it is you're talking about, then really what you're trying to do is find out what numbers exist, whole numbers, no decimal points anywhere, whole numbers, so that you can end up multiplying them together to give you 10. So you notice the number 3 is not on the list. The number 4 is not on this list. And that's because the number 3, for instance, you can't multiply 3 times anything to give you 10. You can't multiply 8 times anything to give you 10. You can't multiply, 4 times anything to give you 10. So they're not factors of 10. When you say something is a factor of 10, it means that that number can be multiplied by something to give you 10. That's basically what it is. The numbers in this list can all be multiplied by something. 1 can be multiplied by 10 to give you 10. 2 can be multiplied by 5 to give you 10. 5 can be multiplied by 2 to give you 10. 10 can be multiplied by 1 to give you 10. But there are no other whole numbers that you can multiply by something to give you 10. Let's pick another example. Something that would have a few more factors. The number 18. Nice, simple number. You've You should be too scared of that. Well, let's start talking about what times what can equal 18. Well, we know that 1 times 18 can equal 18, right? We know that 3 times 6 can equal 18. And we know that 2 times 9 can equal 18. So we have a lot of numbers that can be multiplied together to equal 18. So the factors of the number 18 are, you might guess, 1, 2, 3, 6, 9, and 18. 1, 2, 3, 6, 9, 18. Now I'm putting them in any, I'm trying to put them in ascending order, but it really doesn't matter the order that you list them. These are just numbers, could be listed in any order that you want, such that every number in this list can be multiplied by something else to give you 18, you know? I mean, we already proved it up here, but 3 can be multiplied by 6 to give you 18. 9 can be multiplied by 2 to give you 18. 18 can be multiplied by 1 to give you 18. That really is all there is to understanding the concept of a factor. It's just a list of numbers, and when we get to algebra later on in the actual letters and variables, we'll learn to expand this definition just a little bit, but it's going to be exactly the same idea. Basically, it's the stuff that you can multiply by something else to give you 18. Now, let me just point one thing out to you, that I keep saying it over and over, that everything in this list of factors can be multiplied by something else to give you 18, which is true. But that's just another way of saying, it's another way of saying that all of the factors of the number 18 are basically, can be divided into 18 evenly. In other words, 18 is divisible evenly by all of these numbers. 10 is divisible evenly by all of these numbers. So that's sort of just another way to rewrite the definition of what a factor is. A factor is a number that is evenly divisible into whatever number it is you're after. So if you're looking for the factors of the number 10, then all of these numbers that you list should be evenly divisible in. And that's exactly because what we said before, they have to be able to be multiplied by something else to give you that number. So let me write that down, just so you'll have it fresh. So another way to say this, just to kind of summarize the definition that we have above, is that all factors, and factors are the list of numbers that we get here in the end, of a number, all factors of a number can be evenly divided into that number. And just to be absolutely clear, I'm going to put with no, this means with no remainder. And no remainder just means that there's nothing left over, so it divides evenly. So you might look at this and say it a different way. What are the factors of 18? Well, all you need to do is pick numbers that can be divided into 18. 18 can be divisible by 2 with no remainder. 18 can be divisible by 9 with no remainder. 18 can be divisible by 6 with no remainder. It's exactly the same definition. There's nothing different here. We're just saying it in a different way. And so just to absolutely, hone it home, we'll just go ahead and say, going back up to our previous example with the number 10, for instance, 4 isn't a factor. And why is 4 not a factor? 4 is not a factor because 4 is not, cannot be divided into 10 evenly. In other words, 4 can't be multiplied by anything to give you 10. It's the same way of saying that. 6 is not a factor. Same thing. 6 cannot be divided into 10 evenly. It can be divided into 12 evenly. It cannot be divided into 10 evenly. So if you go down to 18, 7 is not a factor. Because 7 cannot be divided into 18. You can divide 7 into 14, but you can't divide it into 18 evenly. 5 is not a factor because you can't divide it in there. So it's really saying the same thing. I'm just giving you a couple of quick examples. Factors are really, really important. You look at this and you say, well, he's teaching me this stuff about factors and numbers, not really that big of a deal. But trust me here, factoring, extremely important. I'm teaching it here in terms of numbers. But in a few sections, we're going to start talking about algebraic expressions, which are just have numbers and letters in them. And frequently you're going to have to factor an expression, which just means doing what we're doing here, but it's going to be a little different because we're going to have some letters involved. But the principle will be the same. See, knowing that a factor can be divided evenly into the number and that's a definition, extremely important. So remember that. We're going to do some more problems here in a minute. Now I want to switch gears to the other topic in this section called multiples. Multiples are very, very important also. A lot of times dealing with fractions, finding common denominators, things like that. Well, let me ask you one thing. What do you think of when I tell you something's a multiple of something? What is a multiple of 2, for instance? A multiple of 2 would be 4, or a multiple of 2 could be 6. In other words, it's when you take the number that you're looking at and you multiply it by a whole number. So let's go ahead and write a definition and show you what I'm talking about rather than talk.